Hello everybody, I will start my today another live coding session. So in my today's video, I will solve this question. Insert, delete, GetRandom of 1. So in this question, I will implement the randomized set class. And for this randomized set class, I have a constructor which initializes the randomized set object. And also I have 3 more methods. Number 1, insert method. So insert an item bar into the set if not present. Returns true if the item was not present, false otherwise. Okay. And also I have remove method, which removes an item bar from the set if it present in the randomized set. Returns true if the item was present and then removed, and false otherwise. And I also have GetRandom method. This returns a random element from the current set of elements. It guarantees that at least one element exists when this method is called. Okay. Each element must have the same probability of being returned. Okay. And I must implement the functions of the class such that each function works in the average constant time complexity. Okay, good. Okay, so I will implement the randomized set. Basically, it looks like just a hash set. Yep. With hash set, I can do insertion and removal in the constant time. So basically, it looks like working. But I also have the GetRandom method. And I have to return a random element in the set, in the constant time, in the same probability for each element. So this GetRandom method is a kind of challenge in this question. Okay. So I'm pretty sure of the question statement and what I will be implementing. I mean the interface. So yep, let me look at this question with some example. So firstly, I have the constructor, which works in this way. Then I have insert method. I can insert any element like this, and this returns true. And now the set has only 11, element 11. And when I try to call insert 11 again, this should return false because 11 is already in the, randomized set. Okay. And I also have the removal method. If I say remove 11, this should return true and this becomes an empty. I mean, internally, the set has no element. Also, if I try to remove an element which is not in the, randomized set, this returns false and there's nothing happening internally. Okay. So these are how insert and remove works. And for GetRandom method, let me add some more element again. Like this. Okay, so in this case, if I call GetRandom method from here, what happens is that this returns 11 or 22, 50-50. Because I have to return 11 or 22 in the same probability, which means both of them should be returned in 50% probability. So this is what I will implement in this question. Yeah. So I will think of how I can realize this functionalities. So the first idea, using the hash set, as I said first, it works pretty well in insert and remove method, but actually it doesn't work on the GetRandom method. Let me show you why. So I have the internal set like this, and say if I have 11, 22 in the set. So what I want to do from here is I try to get element 11 or 22 from this set. And for this, it seems like I can use the Python's helper function, random choice. Yep, like this. But this doesn't work because random choice cannot take set as an argument. It has to take the prescriptable, no, I mean subscriptable object like list. I mean index element, or indexed list is what it needs. So if I do this, okay, I copy pasted something here. So it raises a type error, so I can't use it. So in that sense, I cannot use internal set only. Okay. So let me think. If I use the internal list for this, let's call it bars. Yeah. In this case, GetRandom works fine with random choice. However, for insert, or maybe insert 22, I have to know 11 is in bars or not in the constant time. Similarly, I have to know whether 22 is in the list in the constant time. This is not possible. Similarly for removal, say I have to remove 11. I have to know if 11 is inside of the list, and also I have to remove 11 from the list. It's not possible because I have to take a look at each element to confirm if 11 exists in the list. So this doesn't work. However, if I use internal bars, not only bars, but also with set, let me try it. So if I'd like to know if 11 is in the bars internally, I can take a look at the set and I can say, yes, it is. And I can remove 11 from here. However, the problem here is that I cannot know where in the list 11 is. So this still takes a constant time until I find it in the list. So this still not enough. But if I have the index like this, yeah. So in the bars map, the key is the bar in the randomized set, and value is the index in the bars list. If I do this, if I'd like to insert 11, I can find 11 is in the bars from the hash map, so I can just return false. And if I'd like to include 33, I can just include it in the firstly in the set. Because it's not in the bars, I firstly append it in the list and as the mapping to the hash map. So insert works in the constant time, and for remove, if say I'd like to remove 44, it doesn't exist. I can find it from the hash map. So I just return false. And if I'd like to remove say 22 from the map, I can find that the index is 1. So I will take a look at this index 1 in the list. And a bit of the trick from here is that I'd like to remove 22, but if I just remove 22 and shift 33 to that position, in that way, it takes the all event time, linear time, because I have to shift all the elements greater than 22. However, one technique is that I firstly swap 22 and 33. And in that way, it's sorted in this way. And when I do this, obviously I have to update the map too, so that they're swapped. Then I remove this element. Now 22 is in the tail, at the tail of the wrist. I just have to pop out. Then when I get 22, I can remove this 22 mapping from the hash map 2. So this is how it works. So in this way, I could do the remove method in the constant time. And for GetRandom method, as I showed here, I can use random.choice with the list, both list. Yep. So it works in the constant time. Okay, so in that way, all the operations works in the constant time with the combination of list and hash map. Okay, that being said, I will start my implementation. Okay, let me quickly explain the insert method. So if the new value is already in the value2 index hash map, I return false because I can't insert it. Otherwise, I append it to the list first in line 53, and I get the index in the list of the new val. Yeah. Then I register it into the hash map with value to value index. Okay, good. And for remove method, okay, let me quickly implement GetRandom method because this is much more simpler. Okay, I use Python function random.choice, and I pass the reserved.bars list. Good. Now I implement the remove method. Okay, if the new value is not in the correction, I just return false. And if it exists, as I shown, I had a few steps. So firstly, I get the bar index from hash map. Now I got the index, like 22 is now at index 1. And next thing I will do is swap it in the swap that element 22 in the list and also in the hash map. So this is a last bar index, and what I will do is swap in the list. Okay, so here I swap in the hash map. Then I swap them in, sorry, I've swapped in the list. Now I will swap in the hash map. Okay, so let me say last bar is like this. Okay, so now I've swapped. The last thing I will do is pop it out from the list and also from the set. I do this. And also I will delete it from the hash map. So okay, I do it in this way. Good. So let me review my remove method again. So in line 58, if bar doesn't exist in the current collection, I return false. Otherwise, in line 61, I get the index in the list of that bar. Then in line 64 and 65, I get the information about the last bar in the current list. Then in line 66, I swap last element and the bar in the list. And also in line 67, I reflect that swapping to in the hash map. Okay. And now in line 70, I pop out the last element from the bars list, which should be the value to be deleted. I confirm it. And in line 71, I delete that from the hash map too. Good. Oh, and I have to return true. Oh, similarly for in line 55, in the end of the insert method, I have to return true. Okay, this is it. Good. Now let me walk through my code with some example. By the way, space complexity should be O of n, assuming that there are n calls in the past. In the worst case, I keep inserting new element in the n calls. So in that case, the list has the ranks n, and also hash map has n key value pairs. So in total, it should be O of n space complexity in the worst case. Okay. So out of this implementation, I will focus on the remove method because it's the most complicated one. So I will walk through only the remove method, and if there's a problem in other method, I will come back after submitting my code. Okay, so let me take a look at this example. So if I do insert twice, now internally, this should have 11 and 22 if my insert logic is correct. And bar to index hash map should have this hash map. Okay. And what I will do from now is try to remove 11. Okay. Oh, let me do with this. just in case the implementation is firstly return true, and secondly self.bar doesn't have 33 anymore, and also same for hash map. Okay, in line 76, bar 11 is in the hash map keys. I go to line 79. Now bar index should be key 11 in the hash map, so it should be 0. Okay, and in line 82, the last value should be the last element, which is 33. And Rust bar index is length to series -1 is 2. So for good. Now I swap bar index and Rust index in the list. So bar index is 0, Rust bar index is 2. So now it becomes like this. Okay. And then I go to line 89. Oh, sorry. I take a look at line 87. And bar index for bar index 0 and for Rust index 2. Yeah, the hash map is updated. So now wait, this is not correct. Key should be value. This should be bar, and also this should be last bar. And here, this should be index. So value is now at the tail, so this should be last bar index. And the Rust value should be where the originally the bar was, so it should be this. Okay. So bar to index bar, which is 11, is updated with Rust bar index, which is 2. No update on 22. And for 33, I mean, for the second one, last bar, which is 33, yep, the key should be now bar index, which is 0. Yep. So I can find that the swapping is correctly reflected to the hash map. Okay. Then in line 91, I pop out element from the bar's list. The 11 is now popped out. And yep, this is equal to bar 11. Good. And then line 92, bar to index key 11 is deleted. So this one is deleted. Okay. And I return true. Good. So now it meets the expectation because I return true. And also in the hash map and also list, it has only 22 and 33. And the mapping in the hash map is correct. Okay, so I'm pretty confident in my code, especially remove method. So I execute my code. Oh. Last index is not defined. Yes, it should be last bar index. Oh, and here too. Okay, I submit my code. Good, accepted. Okay, so let me quickly wrap up my today's code practice. Oh, wait. So, oh, wait. My screen is not reflected. Oh, it now updated. I think I couldn't share the implementation of remove and also the walking through. I use this example. Okay. Yeah. For now, I will, wrap up all this it. Okay. So in this video, I solved the question, insert the read get random of one. So my task was to implement the randomized set class, and it has three methods: insert method, remove method, and get random method. So aside from the original, ordinary hash map, the hash set, I needed get random method. And to realize them to be returned in the constant time, I used the two internal data structures, list and hash map. Hash map is the value to the index in the list. Yep. Okay, so in the insert method, I pop the element into the list and also register that new entry into the hash map. Yep. And for remove method, this is a bit tricky. I firstly get the index of the removed value from the hash map. Then I swap that element with the last element in the list. Then I reflect the change into the hash map. Then I delete the value in the list, which is the last index now. Then I also remove that entry from the hash map. That's how it works in the remove method. Okay, and for get random method, I just have to use the random choice method of the Python with the list giving us the argument. Okay, in this way, all the operations are done in the constant time. Yep. I wrap up my today's coding practice with this. Thank you so much. Bye.